Okay, so we're going to go over the Unit 2 study guide review together. Your job is to fill this in. So number 1 says, a baseball is thrown vertically into the air from the ground. That would be 2.2. Describe the velocity and the acceleration at each of the given points. Notice point A, B, C, and D. So at A, right? At A. I don't want to do that. At point A, the velocity is positive, the acceleration is negative. At point B, the velocity is 0, the acceleration is still negative. At point C, the velocity is negative and the acceleration is negative. And at point D, the velocity is negative and the acceleration is negative. Okay. Question number 2. An object is thrown straight up from the ground with a speed of 40 meters per second. What is its distance above the ground 1 second later? Well, this is a question where you have to utilize kinematic 2. Y is equal to y naught plus v naught t plus 1/2 at squared. Because we know y naught is 0 plus v naught, which is 40 times 1, plus 1/2 times a negative 9.8 times 1 squared. All right, grab that handy dandy calculator. This is 40 times 1 plus 0.5 times a negative 9.8 times 1 squared. Gives you a height off the ground of 35.1 meters. Question 3. An object is thrown straight up from the ground with a speed of 40 meters per second. What is its velocity above the ground 1 second later? Well, this is kinematic 1. V is equal to v naught plus at. So v is equal to, because that's what I want to know, v naught, which is positive 40, plus a, which is a negative 9.8 times 1. So what is 40 plus a negative 9.8 times 1? That would be 30.2 meters per second. Notice it is still positive. Okay, notice it is still positive because we're still going up. 4. An object is thrown straight up from the ground level at a speed of 50 meters per second. What is its distance above the ground 4 seconds later? This is exactly like number 2 with different numbers. Y is equal to y naught plus v naught t plus 1/2 at squared. So that y is equal to y naught is the ground, which is 0, plus v naught, which is 50 times 4, plus 1/2 times a negative 9.8 times 4 squared. Be very careful with your negatives. Okay, so this is 50 times 4 plus 0.5 times a negative 9.8 times 4 squared. Should give you 121.6 meters. What is its velocity 4 seconds later? Again, kinematic 1, v is equal to v naught plus at, so that v is equal to 50 plus a negative 9.8 times 4. Now watch this one. 50 plus a negative 9.8 times 4 is 10.8 meters per second. So are you on the way up or on the way down? You should have said on the way up because it's still a positive velocity. Okay. Number 6. An object is thrown vertically upward at 25 meters per second. What is its velocity 5 seconds later? V is equal to V naught plus AT. V is equal to 25 plus a negative 9.8 times 5, right? 25 plus a negative 9.8 times 5 is a negative 24 meters per second. It's on its way back down. Question 7, an object is thrown vertically upward at 25. What is its distance above the ground? Y is equal to Y naught plus V naught T plus 1/2 AT squared. So that Y is equal to 0 plus 25 times 5 plus 1/2 times a negative 9.8 times 5 squared is equal to 25 times 5 plus 0.5 times a negative 9.8 times 5 squared to be 2.5 meters. It is 2.5 meters off the ground. Number 8, a ball is thrown vertically into the air from a height of 50 meters. Describe the velocity and acceleration at all 3 points. So the velocity at A, okay, so at position A, velocity is positive and acceleration is negative. At position B, velocity is 0. Acceleration is negative. At C, now here at C, we could say that at C, the velocity is equal to a negative V naught. Because remember, whatever V naught was, when it passes you, that's how fast it's going to be going. And A is still a negative value. And at position D, velocity is equal to, or velocity is negative, and acceleration is definitely still. Hi, so welcome back. This is number 9. Took me a while to get here. Number 9 says, a stone is thrown vertically upward from a cliff of 130 meters high with an initial speed of 19.5 meters per second. It will rise to a maximum height of what? Now, if you remember, this was where we had some linked situations happening. So the equation we need is, undo that. The equation we need is y is equal to a negative V naught squared divided by 2a plus your y naught. Okay. So in this situation, grabbing your handy dandy calculator, this would be 19.5 squared divided by, now we're on Earth, so gravity is 9.8. So that means 2 times 9.8 is 19.6. And I'm just going to put 19.6 in my calculator so that I don't have to worry about am I really dividing or adding? And then I'm going to add my 130 back in so that I get a height of 149.401 meters. Then when I go to do number 10, sorry, that wasn't zoomed in very much. When I go to do number 10, a stone is thrown vertically. It's the same question, it will have a velocity of what at the top of its path? Always be sure you read the question carefully. The velocity at the top is always equal to 0 meters per second. Number 11 is a linked part, right? Stone is thrown vertically up toward from 130 meters, initial speed. It will rise to a maximum speed. Notice it says speed, not velocity, of what at the ground. So I'm looking for the velocity at the bottom, which is the negative square root. Negative square root, there we go, of 2ay. But remember, this is linked. So now I need that negative square root, right? So this is a negative square root in my calculator of 2 times 9.8 times my height, but it's not the initial height. It's the height I found way up here in number 9. So it's 149.401. Insert square root. Okay, let's try this again. This is the negative square root of 2 times 9.8 times 149.401 to be a speed. Notice it does say speed, so I don't need the negative sign. 54.113 meters per second. Okay. Number 12 says, a stone is thrown vertically from the height. What is its total hang time? Well, you were never asked to find the time up. So the first thing we're going to go do is find the time up. Time up was negative V naught divided by A. So on your calculator, this is a negative 19.5 divided by a negative 9.8 to be 1.9899 seconds going up. Then we need time down. That comes from the square root. I'm just going to go copy my little symbol up there. That comes from the square root of 2y divided by a. But again, this is linked, so you had to find number 9 before you could find the rest of these. Okay, so number 9, that 2y, this is the square root of 2 times 149.401 divided by 9.8 to give us a time down of 5.522 seconds, which then gives us a total time of adding those two together, 1.99 plus 5.522 of 7.512 seconds total time. Number 13, a projectile is shot vertically upward from ground level with a given initial velocity. It reaches a maximum height of 100. What was its initial velocity? All right, this goes back to 2.2. So hopefully you have those 2.2 notes. I'm finding mine as we speak. 2.2 notes. Here you're given a maximum height, and it is asking for that initial velocity. Well, remember, if you have a maximum height, your initial velocity, or better yet, negative your initial velocity, is equal to your velocity at the bottom, which is equal to the negative square root of 2ay. So this is the square root of 2 times 9.8 times 100, or a maximum an initial velocity of positive 44.272 meters per second, because that's what it's going to come down at. So that must have been what it was put up at. Projectile shot vertically upward from the ground with a given velocity. It reaches a height of 100. What was the final velocity when it returned to you? Well, since we know VB is equal to a negative V naught, and we have V naught is 44.212, that means VB is equal to the negative 44.272 meters per second. 15. Shot vertically upward, 100 meters. How long did it take to get to its maximum height? Well, that is time up, which is equal to time down, which is equal to the square root of 2y divided by a. So this is the square root of 2 times 100 divided by 9.8, or 4.518 seconds. And finally, it says number 16, shot vertically upward, given initial velocity, reaches the maximum height of 100. How long was it in the air? That is asking for total time, which is simply time up times 2, which would equal 9.035 seconds. Thanks for watching.